I, I, Mr. Udainikam, welcome you all for 5 days FDP on electric vehicle design to product development. Our guest speaker for this session is Mr. Kartikesh Kumar. I take this opportunity to welcome and introduce him. Mr. Kartikesh Kumar sir has done his BE in electrical engineering at Dr. T Institute of Technology, Bangalore. He has completed his master's in electrical engineering in power electronics and drives from Birla Institute of Technology, Mesra, Ranchi in Jharkhand. Sir is presently pursuing PhD in electrical engineering at National Institute of Technology, Patna in Bihar. Sir has worked as junior research fellow under the project entitled Design and Development of Low-Cost BLDC Motor Drive for Solar PV Irrigation Systems. He has an experience in power electronics and drives, solar PV, DC and DC converters, and BLDC motor and inverters. Presently, Sir is working as an application engineer in ARK Info Solutions Private Limited, and he is lead business partner at ANSYS. Once again, a very warm welcome to you, sir. I request you to start our today's second session. Over to you, sir.
Okay, thank you, sir, for this giving me opportunity. So, am I audible, sir?
Yes, sir. You're clearly audible.
Okay, sir. Let me share my screen. Is my screen visible, sir? Design
Yes,
and optimization. Okay,
yes, sir.
thank you,
Yes.
sir. Thank you, sir. So, in the we are here basically to give you or provide you opportunities related to if you are electrical engineer, if you are mechanical engineer, or if you are doing you want to start your startup. So there are many government funds are also available for going for a startup, and how ANSYS will basically help you in doing that. So in today we will basically go for designing and development of EV drivetrain. I am Kartikesh Kumar from ARK Info Solution, and I am a certified application engineer. And in that, let me introduce something about ANSYS. ANSYS will basically help you in ideation part. If you have an idea, that blueprint of your thing, and you basically want to check, if you are want to improve something in your motor design part and in power electronics part and in any other part of EV, like battery system and battery management system. So you just have to lock your idea, and by using the answers you can also check my idea is going in the right direction or not. So we can do that by using the ideation, and then going to that design part, we will design it, and answers will basically help you in designing. It will reduce your timing. And when after designing and analyzing, you will go to manufacturing part. And before going to that manufacturing part, if you design your whole system in a simulation, and after simulation it will basically give you information. So from based on that information, you can easily able to reduce the weight of your whole EV system by 25% by going to that topology optimization. And operation is also there, so you can also by using that you will also perform 10 say 20% reduction in maintenance cost by doing this whole process before going to prototyping your whole model. Like you are going for product development, first you just have to simulate it, and you have to put factors like aerodynamic force is there, gradient force is there, so that forces and rolling resistance force is there, so that forces you just have to go through that, and you just have to calculate the values, and then you have to go for final hardware designing part. So what answers will basically give you, answers will basically give you a multi-physics information, and by using that multi-physics you will get a platform. In that platform you will have a material information, and answers have a granta material. From that you will get more than 2000 material information available there, and you can also user defined material things is also available, so you can also do that. And by that you will go to that fluid parts, you can do the fluid analysis, you can do the structural analysis, you can do electromagnetic analysis. In that you will do the motor designing, low frequency and high frequency analysis, and you can also do the noise and vibration analysis. So these things will come under this electromagnetic magnetic part, and semiconductor power, and you can also do the optical analysis by using this, and you can get a fair idea about your product designing part. And these are our world class partner company partners, and you also know the names of Airbus, ABB, and BMW, PNG, and the Pfizer is right now very much famous because of vaccine. And the next, these are our partial list of the academic customer of the answers in India. Many elite institutes are our partners, like from IIT to NIT, and from that BIT and the other colleges. So what answers will basically provide you solution for the electric vehicle. uh, Answers will basically give you a design and development for EV. It will basically provide you a virtual lab, and that virtual lab you can assess anytime, anywhere, and at any scale. Like if you have designed a prototype and you want to change the motor from induction motor to PMSM, or you want to change that motor type and the controlling technology, you just want to like P controller, PID controller, and many other things are there, like incremental conductance method, and the many other, like you want to change from the solar driven electric vehicle. So same prototype is used for the other, you just only have to change the machine part. So that was the advantage. It will basically provide you a virtual lab type of information, and in that you can do the fluid dynamics, structural mechanics, electromagnetic system, and the material science. These are the available in the answers, so you can do that analysis. So what are the main pillar and what are the main areas of electric vehicle? So if we categorize that, it is divided in four parts, like battery and the battery management system. And in that battery management system we will discuss these things in later coming slides. So before going to that, we will the next part is the important, like electric machine. Like we have IC engines there, we have in EV, we have electric machines. And to how we will control that electric machine, by using the power electronics devices. So power electronics device basically give you information, like like driver wants to run your the motor at 1000 rpm, so that we just have to take care like which and how to control that. So that thing there, power electronics comes a very important information, or power electronics controlling is very important at that part. And after designing your battery, and after designing your electrical machine, and after designing your power electronics, the next thing we have to make our system and to run as a system in an integrated manner. Like whole integration part is there. So how my integrated system will behave if I connect my battery with the machine and with the power electronics, and whole system is completed, how what was the behavior of my machine? So that thing will comes under the powertrain system integration part. There we have to look for the functional safety model and the libraries and the architectural definition. So first we will go for battery and the battery management system part. Like already in the first session you just covered that battery management system part, so I will brief you about that only. In the battery battery design, what was the main motto and what was the main goal? for designing the battery. So the main goal and the main thing basically interested for the people is the power density, charge and the discharge cycle. Like what is the fast charging is in, we can do the fast charging of the battery or not. Like if you are we are going to refuel at the fuel center, and there what you will you just have to wait for 2 minutes and 3 minutes, and there so much hue and cry will happen. So think about the electric vehicle. If you have an electric vehicle and it will take nearly a half an hour to charge and 1 hour to charge and discharge, charging of that battery at the charging station. So that will basically give you a headache for the customer. So that problem you just have to address it, like how I can provide and what facility I will provide to for the fast charging. So that thing we also think about it when we are going for designing of our electric vehicle. And the second thing is the most important, like charger, battery charger is there, like wireless charging is important. And the other charges information, charging information, like if you have a battery and you are charging that battery, and that battery involve many other components except motors. It has to control the other drives which is working on 12 volt, which is, and some other are working in 6 volt. So you just have to look that part also. So before going to that, you can see here the sale design team. That sale design team basically involves, and the main work basically the sale design team will do is the optimize cell and the electrode performance. And after doing that cell design, we basically want a thermal and the mechanical team for the battery reliability and the module pack system. And we also required information like EMI, EMC, like EMI, EMC, because we basically want to protect from the noise. So we want to provide a shielding and the component selection for designing the filters. And then we required a software team for designing that battery management system and system integration part. So first, you can also show one paper is cited as a where that the 3D model, that 3D model which is designed in ANSYS will basically predict a consistent information there, and the consistent with the experimental result which they got. So you just take like you are designing a cell and you are doing something, you just want to change that, like lithium ion batteries there, and you are basically want to go for fuel cell or any other cell technology. You just want to change, you want to change the material of electrode. So that thing can be easily designed in ANSYS, and you will get a fair or consistent idea that if I will use that type of materials, what was the information and what was my capacity of the battery will increase or decrease. So anode and cathode information you will get the like mesh on the surface. So these things you will be get when you design your battery part. Like so first step is to design your cell. After designing the cell, what we will do, we will basically pack our cell. Like you designed a cell, and after designing that cell, you just have to make the end plate. And after connecting with the end plate and cell to core to end plate, the next step is to the next step is we have to create the model mesh. Model mesh. Okay. And after using the completing that model mesh part, and finally we just want like what was my the temperature and what was the current density of my battery. So these things can be analyze it easily by using the temperature contour, or that temperature contour will give the information, and the red hot part will come. So that red hot part will basically give you information like that battery is getting heated at that part only. So we just have to analyze only for that part, like that part is getting heated. So how to mitigate that, how to remove that? So we can easily in software we can easily change the values, and we can redesign our whole system, battery system. And after that we can we reanalyze it and check our what was the temperature it is reaching. Because for the battery, one more problem I would like to address here, Like if you are going from Kashmir to Kanyakumari, and the temperature range is varying from one place to another. So sometime battery need to heat up, and sometime battery need to cool down. So you just have to create, or you just have to design such a system that will basically make your battery to be cool up to certain range. Like battery should not be go beyond the my 20 degree Celsius, and battery should not in the battery temperature should not go beyond 45 degrees Celsius and 55 degrees Celsius, because after that more than 55 degrees Celsius, it will not behave perfectly according to your characteristics. So that will basically change. So you just have to cool down your battery. You just have to heat up somewhere. So that thing you just have to be consider when you are going for designing your battery, whole battery system part. And the next, after designing your battery and the cell is designed, and after designing the cell, you just end plate is connected and you created a model. And now battery model and the pack system is created. Now after creating that pack, thermal abuse and runaway mitigation part is very important. Like if you have a battery and that battery is getting heated up to certain temperature range, like you can see here, it is heated at this part. Okay, red hot part is created here. So that red hot part, you just have to create a controller like that. That red hot part should be reduced and come under the range of our temperature range, which is specified. Like you can see in the graph, a good design, no thermal runaway of happen, and for the bad design, the thermal runaway happens many times. So that you just have to go when you are going for designing that battery pack, you just have to go through that. And this is the main and the most important, the important part of your EV. Like if your battery should catch fire, so this will basically ruin your whole startup and whole company. If any fire or any at the accident or any crash happen, this battery should not be burned. So that you just have to be considered by doing the crash analysis of your battery. What was the survival of the battery? So for that, you finally you required a cooling system. Like air cooled system is already there. So you just have to check, like if I will provide a air cooled system, or I have to go for provide a liquid cool system. So how answers will basically help you in that? Answers will like you have designed your whole thermal model, and that thermal model you will basically ECM modeling, and in that equivalent circuit modeling, and that equivalent circuit modeling we just have to connect it in series and parallel for make the thermal model compatible with the hardware or experimental model. And after doing that, connecting that, we will analyze it, and after analyzing we will come to know what was the maximum temperature it is reaching by using the air cooled system. And for that, answers tool like twin builder and the fluent will basically help you in designing that. And this will basically reduce your main timing. That timing is very important in the today market. Like you can see many electric vehicles are coming to the market, but the one question will basically people will ask like kitna deti hai. That is the very important point when you are designing your EV and doing any, because customer will basically ask you a simple question like this, like kitna dete, means they are basically focused on like I will use that battery, I will use your electric vehicle, but I require that much mileage. So that is the very important thing, and the size of the battery is very important. So you just have to reduce the size of the battery and the weight of the battery. If it is reduced, so for reducing that you require a more efficient motor to reducing the size. If your motor efficient, your source side you just have to, you can easily reduce it. And for that or perfectly using that, you require a battery management system. So before going to that, we will first look into the air cooled system. So, like your battery is designed, you have checked with the air cool system, but your air cool system is not able to provide that particular value, like not able to cool it down. So then you require a liquid cool system, and in that liquid cool system, you just cool it down, and you just have to check what was the, like you can see in this example, this point is heated. So we have to do something like that. We will mitigate this and we will reduce this. So that is the main goal. Like we have to check what was the state of charge and the thermal behavior, and after and this like which soft in that part, a twin builder and field will basically help you in doing that same analysis. This is like we have already discussed in air cooled system. So like your battery is created, you have created and you are satisfied with the performance of the battery. The next thing is came under the what was the durability and the safety of the battery, and how to optimize the vibration part. Like your electric vehicle is running, this means you will get a vibration. So what was will my battery will survive the vibration? And for that we required to do the nail penetration test. So that nail penetration test will basically provide, like nail penetration test is there, so that will basically give you abuse tolerance level, how to check that. Okay, and the bidirectional smart meshing is there, and the multi-physics impact like thermal runaway, which we already discussed it. And the next we can also check the vibration part, like if your my electric vehicle is running, and my whole system will survive the vibration or not. So that we have to check by using this. So the next, after checking the battery structure, durability, and the safety, the next step is to battery compliance, EMI, EMC. And in that EMI, EMC part, we can see like your battery is connected to some filter design. You have to design that, and by using that, that EMC, EMI filter will basically help you to detect and mitigate the noises, that noise of from the machine and the noise from the other electronics devices and the noise from the other equipments will not affect the performance of your battery and the battery management system. So that you just have to take care when you are designing your whole system, going for designing your whole battery system. So after designing that battery, now you have to connect the battery with the uh, whole system, like powertrain system. So for that you required a model based system, and you also required a system architecture, you required software component, you required ROM. That ROM is the basically a reduced order modeling. So like now you have connected whole system, and after connecting the whole model based system, and we just have to check, like many safety standards are there, like ISO 26262. So like I have designed it, and after designing I am checking it if it is up to the safety standard or not. So that will also a very important part when we are going for final designing. And then we want we have created our battery and the battery management system, and we just want to connect it, and we just want to check like our model is running up to as a plant or not. So that we just have to check. So how we can do that, how we can check it, like we just have to create a environment like the real time environment, and by using that real time environment we just have to compare. And after comparing your simulation model, like you have designed your CPAC CFD, and that model you and cell HPC test, and you just given to that and connected with the battery management system control, and after that you are doing the transient dynamic analysis, and in that you will able to easily check if that range is reached or it is increased going beyond your range. So that you just have to check it. Okay, and the next you just have to use the connection, whole connection, and electrified propulsion system integration part. And then you just have to check what was the behavior of my battery. So for that you have connected a battery, and you have created, and that integral permanent magnet motor is there. And that motor, this is the characteristics of the motor. So you just import that motor part is here, traction motor PMSM, and that PMSM part is connected with the power electronics devices, and that is the power source, like battery is there. So in battery, power electronics device is connected and the motor is connected, and what was the behavior of my the whole integration system. So you just have to look into that, like my battery is running or performing good or not, so that we will easily able to check it. So this will basically reduce your timing, and this will basically give you a accurate predictive system. And you can also say see, like if I will do the same simulation like I have done the in same simulation. So if you import that simulation to the hardware, going to that hardware part, you will get a result, same result like a simulation. And for that you required components like if you are going for battery design and development solution, you will require a ANSYS Fluent and or LS Dyna for the crash analysis. You require ANSYS Mechanical for CFD part. You require ANSYS Twin Builder for importing or exporting from and making a communication co-simulation and multi-physics co-simulation. So that will basically give you ANSYS Twin Builder will basically help you on that. And if you are going for battery management system, then ANSYS Fluent and ANSYS Twin Builder will help you out. Okay, and after designing the battery, now you are designing a electrical machine. In that electrical machine, the what was the main goal? The what was the energy efficiency of my motor? What is the power density of the motor? What was the size of the motor? And like you want to make a small electric vehicle, then the size of the motor cannot go beyond a certain limit. So that size is also important. What was the material involved in designing the motor, like permanent magnet involved or not? PMSM and if BLDC is there, then permanent magnet is involved. So that also we just have to look into that, the availability of the materials and the designing part. And in that you will require fast innovation. And for the fast, you require the electric machine team, and that they will they will basically give you information. They will basically provide you information about the torque, speed characteristics, and what was the efficiency map of my motor. So they will basically provide you information related to this. And the next is the thermal design part. In thermal design part, what was the temperature my motor is reaching, so, and what was the behavior of BH curve of the motor, material of the motor. So that will be basically very useful when you are going for final and the prototyping of your designing. And the next thing is the CFD team. In that, CFD will basically give you like how to design a optimized cool strategies, and what was the noise and vibration. That noise and vibration is also important, because your electric vehicle is not sitting at one place. It is basically like electric vehicle is moving. So that noise and vibration, and that noise and vibration will sometime also affect your, if you are going for automated electric vehicle, so that noise will not affect the whole system behavior. So you just have to check that part also. And then you will come to know about the control and the software team, that control integration part is there. Like you have provided a drive cycle, like IDC is the Indian drive cycle, is basically used for IDC. So and MIDC is the modified Indian drive cycle. So that drive cycle, for that particular drive cycle, what was the behavior of your motor? So you can also check that drive cycle part to check your motor will run perfectly or not. And if you include slope part also, you can also check your motor performance. So the main thing is the design and specification, like what motor we have to select for the particular application. Like if you are designing for e-rickshaw, so in that e-rickshaw there is a constraint that you cannot go beyond 25. Speed should not go beyond the 25 kilometer per hour. So that you just have to check, like we just have to take consideration of motor, like which motor I will select for that particular application, and like selection of topology. And the next step is to check efficiency map, and what was the flux density. So you just, and for that answers will basically provide you a motor CAD, and in that motor CAD you can do the magnetic analysis, thermal analysis, and mechanical analysis, and you can do the efficiency mapping and the performance analysis using the drive cycle is already present there. So for doing the fast calculation and fast checking your performance of motor, so you can use answers motorcad for that. So that will be, and you can also do the optimization part there. And in that optimization part, like you want to reduce, there are many factors that will basically involve in the designing of machine. So you can also, like slot number is there, number of, and length, and what was the magnetic length, and what was the angle between the magnet. So that will also a very important. So you just have to check it, like if I changed something in the design, what was the behavior I will get. So you by easily you can do it in answers motorcad, and this will basically give you the, and easily it will give you the thermal performance, and you can easily able to predict the performance in the at the development stage. So after, and then we have to select the, what was the advanced magnetic analysis. In that advanced magnetic analysis we can do the like we can select the material, and by selecting the material we can also use a simulation through HPCs are there. So that HPCs are nothing but the high performance computation for the electromagnetic modeling. So this will basically give you information about what this will basically improve the performance in greater detail. This will also give you information about the material, like you are using a material, so that material characteristics, BH curve, and the many performance trade-off. So you can also check it, and you can also check the what was the demagnetization, magnetization, and robustness of your motor. And you can also do by using the optimization, you can also reduce the cost reduction part. And after designing your motor, the main thing comes is the efficiency map and the torque speed. So that efficiency map, you can see here a efficiency map of a motor is there, and the dot is the basically, and the blue dot is basically a driving cycle imported in the efficiency map. So from that driving cycle part, you will come to know that at the time of starting, what was the behavior, like what was the starting tap torque at the starting at the low speed, and what was the after reaching that 4000 and the 8000, what was the behavior of torque and the speed. So you just have to check that. And you can also come to know about the performance of your motor. So you can also do that part. And answers will basically provide you a machine toolkit is there, and in that toolkit you have to select the what type of machine you are interested in, what type of control strategy you are interested in, and you can basically run your machine. And you can also see here, like experimental result is here and simulation result is there, and you have done your simulation in answers, so that simulation will basically accurately predict the electromagnetic performance. So you can, this will basically give you information that you can believe on the simulation part, like if I'm changing such changes I'm doing in my simulation part, what was the characteristics and what was the behavior of the motor, I will get it in the experimental, so that we can also check it and compare it. And the next part is the thermal management part. Like you have designed your motor, and now you just want, like we have designed a battery, and the same thing, we have to like cool our battery also. So here we just have to cool our motor. So for cooling that motor part, we have to like we have a magnetic field, like EM loss component, magnetic core loss, and the copper losses are there, and then we want to map that losses and to the thermal management, and from that temperature we can also map it. And after doing that, we can easily like you can see here oil spread cooling is there, so you can also like you can also change that cooling part. Like our one of the customer lucid motor, they basically increase the efficiency of motor by doing that temperature prediction part. Like that my motor is like you have designed a motor and you only some part your motor is getting heated, so you just have to take care of that part only. And if you take care of that part, and then you able to increase, or you can also go increase the rated temperature, and you can also increase the value of the like effect. You can also provide your motor to effective cooling, and you can also reduce the size of your motor. If efficiency is increased, then for the whole the same for the same system you required like if you are using 3 HP motor, now you require 2.5 HP motor, so you just have to look into that. If your motor efficiency will increase, whole overall system like motor is efficient. I'm getting 3 HP with a small motor, this means the size of the inverter will also reduce, the size of the battery will also reduce. So we just have to look into that motor part more, like designing of motor and optimizing the size and the optimizing the material which is used is very important. And you have designed your motor. Now noise, vibration and hardness analysis is very important when you are going for design final giving your motor a final like selecting your motor. So that noise vibration test by using the MBD, multi body dynamics, we designed it, like you have already designed it your motor, and then we have to use by using the realistic sound. So that will basically create a V shape or the waterfall diagram. So that waterfall diagram will basically give information about the noise, and where then the more noise part, what we will do, we will basically easily able to detect and then remove it. Like for example, you can take like you are moving in an electric vehicle, and that electric vehicle, you are going in an electric vehicle, and that electric vehicle you are getting a noise. So that will basically not give and for the passenger comfort. So that will basically we have to take care of that noise part, and we just have to find the point where it is we are getting a no less noisy things, and that noise will not like if you are going for a like automated system, and that automated system will not be affected by the other noise, so we just have to take care of that part also. And after removing that noise and vibration, the next part is the multi physics traction motor design optimized. Like you have designed your motor, and okay, and after doing that you like you have designed your motor, and you have done your noise and vibration part over, and now you want to optimize your motor. So mechanical information will be put to that optislang, and design parametric information will also be given, and by ANSYS Maxwell you will give information like efficiency map to the optislang, and that information will be exchanged between Maxwell and the Fluent. And from there in the optislang part, x-axis is like thickness, magnetic thickness, and y-axis is the other, and the magnetic coverage, and so these are the parameters which you basically want to optimize. So by doing this, you can easily increase your efficiency up to 2%, and you can easily reduce the weight 10% and make your motor to be less noisy or the quieter, and this will basically be reduce your timing. Like whole if you go for directly hardware part and if any problem is there, so you cannot change it directly, but in software if you get the problems, you can easily detect it and you can easily mitigate it, and so this will basically reduce your whole cycle time from 6 months to 4 weeks. And after like your motor is already designed, the vibration test is already done, and after doing this we are controlling our motor, like how we can control it. So for controlling that motor, and you can also use HIL integration part is also there, hardware in loop, so you can also control it by using this hardware in loop method. And you can also use ROM, reduce order modeling is there, and by using that in the twin builder we can connect our motor with the power electronic devices and source control, like connected with inverter, and check what was the performance of my whole motor. So we can do this by using HIL, hardware in loop process, and that will basically help you and giving you final information about the performance of your motor, and when you connect it with the power electronics inverter, what was the behavior. And in with power electronics devices you can also do the what was the switching frequency. So we will go one by one there. So after doing that, designing your battery, we have designed it, we have designed the motor, and these are the for the particular application, particular answers product is required. Like if you are going for a motor cooling system thermal, so that required a motor CAD to design a motor. And after designing you required ANSYS mechanical for the vibration, and the ANSYS fluent for the fluid part, and the granta for the material, and OptiSlang for the optimizing your whole system. So by and the many other like ANSYS Maxwell is already used for the battery part, so that is same for the motor performance and the motor control, and you required, and the for optimization system and power electronics you required extra one more thing, like ANSYS Twin Builder for designing your motor. And you will get product information also, like www.ansys.com. And the next like you have designed your motor, you have designed your battery system, and now you basically want to control your whole system. And for controlling you require a power electronics design and development part. And from power electronics, what we basically want to reduce the losses, and we basically want to make a efficient system, like noise and over voltage should be reduced, and overall protection should be there, and what was the lifetime of the whole system will increase, and the losses in the power electronics devices itself should be reduced. So these things we just have to take care when we are going for that power electronics part, and controlling that whole system, and the reliability should be there. And for the electrical system, like system and the circuit, so electrical people will basically do the optimization system and the circuit designing and efficiency part. And for the mechanical will people will basically do the reliability analysis, and they will basically help us to mitigate the future component failure. And the software team is basically helpful in embedded control system, like 10 electric vehicle are automatically running, and they are taking information from the cloud. So that information should not hamper, like some car is wants to speed up and some car is wants to speed down. So the exchange of information from the cloud to this, to the EV electric vehicle, should not get mitigated or should not get hampered by the other. So this will be cause a lot of confusion. So the software team is very important there to control and detect the flaws and designing and the testing part. And after that we required a magnetic analysis to check what was the power density, and what and the thermal management for the mitigation of component failure is there, and EMC is there for the reduce the noises. So first the the first and the main step is basically involved here is the optimized system and the circuit design. Okay, so like we have whole system, and that system should be optimized. That is the main thing. And you are designing, like you can see here, a regulated flyback converter is there. And before going to that detail, like you have a DC machine, and in that DC machine you just want to control the speed of your DC machine. So for controlling, you required some controller. Okay, and for controlling, like you have a battery of 48 volt, and your motor you have designed is 310 volt. So how to connect that 48 volt with the 300 volt? So for doing that, we require power electronics devices. Like DC-DC converter should be there to increase the voltage. Sometime we have sometimes we have to decrease the voltage. So there we required boost converter, buck converter, and for that, for increasing and decreasing, what we will do, we will basically have to use the cup converter. So accordingly, we just have to plan accordingly, like which topology of the converter we have to select. And some part of your, like you have connected a music system with that battery, so there you require a different power level and different voltage and the current level. So we just have to design the such the, and the power electronics devices are very important there. Somewhere we want to increase, somewhere we want to decrease. And one more thing, like your power electronics devices will be intelligent enough to give you information like state of the battery, and what was the state of the charge of your battery, and what was the health, SOH, state of health of your battery. So that will information will be given by the circuit design. And one more thing, like you can see here, regulated flyback converter is connected. And in that flyback converter, like you have a inductor part, and you want to analyze what was the behavior of the inductor in the converter. Like if you have a DC-DC boost converter, you have a inductor in that, and you have one capacitor in that, but the cost of the inductor is more, so people are basically focused on the inductor behavior. So in that inductor, like inductor, what was the switching frequency I have to put? Like if you increase the switching frequency, then boosting, and you will get a smooth DC output. So for smoothing of that, and what was the filter I am using for smoothing, like I am connecting a capacitor, what was the range of that capacitor? So the calculation involved on that, size of the size of the capacitor, size of the inductor, size of the, and which type of switching device I would select. Like I will select MOSFET, I will select BJT, or I will select IGBT. So according to our requirement, we have to precise, we have to select the component rightly. Then our whole system will behave good. And what was the switch on and off losses? So that part also we have to be considered when we are going for power electronics. And you can see co-simulation with the 3D physics. Like 3D physics is involved, and like EM, electromagnetic, fluid, thermal, and mechanical, whole designing part. And we basically want whole analysis in one page. So for that required ANSYS twin builder, and that ANSYS twin builder will basically give all information in one page. And like you can see here, like we have exported and imported. We can also do the import and export, and we can also use the third party tool system like GT, Simulink, and from there we can also put the information to the ANSYS twin builder, and then we can analyze like what was the behavior of my whole system, and what was the characteristics I'm getting by using that power electronics device. And what like if I want to check, like I have a IGBT, and in that IGBT we basically want to put the thermal behavior also. by using the ANSYS ice pack, and the many other things are also involved. So you can see here, this will basically give you solution about the multi-domain uh, circuit, and you can get the different power level and the different accuracy level also. So this will basically enable you for broader application. This will basically increase your competitiveness. And after doing that, the next thing is the magnetic. So like you can see here, a cable is there, and in that cable you can see the flux and the other things. And you can also design the electronics transformer, and by using that, like we have connect the PMSM devices there, and we are controlling the speed of the PMSM. So for controlling the speed of the PMSM, we require an inverter, and space vector control is there. So in inverter part, we have connected a IGBT, so that IGBT should behave as the same behavior which we required as a hardware. So that we have to import it by using the data sheet of the IGBT. We will put the all information like temperature range, and what was the characteristics graph information, so that we will put it into this IGBT part, and that IGBT will basically connect it to the inverter, and that inverter will basically run our inverter. And then if we check that inverter part, we will get a perfect information like what was the temperature range of the IGBT we are getting, if we have to change that IGBT with the higher value of IGBT, or if we have to change the only connecting wire of the IGBT. So that information we will get it here. And then like you can see here, a hot spot and thermal limit prediction is there. Like a hot spot is created, that hot spot will basically give you info like heat, that IGBT will be heated at a particular place. So we don't have to go to uh, next extend, or we don't have to, we just have to prevent that component failure. So we just have to take care of that thing. And the next, we just have to check what was the customer goal. That customer goal, or if you are a customer, and if you are a, or if you are a manufacturer, if that hard spot will not good for your whole design, like this will create a burning part and the other thing. So we just have to check it, or we just have to remove and mitigate it. The same you can see here, like we just have to change the width of the wire, or the change the other things like parameters which will basically make this IGBT to heat up. So we just have to look into that, and we just have to check that part and remove that thing. And for that analysis, we required lots of information, and that information will come from the datasheet part, and then we will analyze it. And after analyzing, the next is the embedded control system, and for that we required a skate suit is there, and that skate suit will basically give you information, and this will basically reduce the development time and the cost. And this will also give you information to ensure the safety of your whole created system. Like motor is there, inverter is there, and you are using the control system, and that control system will basically provided you in by using the skate suit. And after that, you required a EMC and EMI certificate. Like you can see here, a radiated noise prediction is there, like noise is there, and we just have to remove it. And this will basically give you like early detection and mitigation part is there. So you can early detect and mitigate that, and you can also reduce the time and the cost by 20 to 40%. And after your whole electronics device is connected in the enhanced PCB reliability part, so that PCB reliability part is also important, and the life prediction of the PCB reliability is also a very important part. Like uh, what was the life of your whole PCB, whole design and whole component, and the so that will be a very important, and that will basically when you are going for hardware prototyping, this will basically help you in reducing the cost of the whole material from the virtual because they are giving information virtual information, so that will basically reduce the cost of your before going to that hardware part, and this will basically easy to use, and this will basically easy help you to determine the failure estimation. And these are the answers product where, and that products are already in used for designing the battery and the battery system and the other devices like motor. So you can see here, like for power electronics you require ANSYS tune builder, ANSYS circuit, and the ANSYS maxwell. So that thing also we are using for the battery battery and the motor system. So now what we have to do, we just have to use electrified the powertrain system integration part. Like we have perfectly designed our battery, we have perfectly designed our motor. Now we have connected with the power electronics devices. Now what was the behavior? So, uh, so for that, like electrified powertrain system design is there. Now what we have to do, we just have to validate our whole system. Like system integration is divided in two parts: component validation and system architecture. And there I also told you, like third party ecosystem is also there, like from MATLAB and the GT suite and the core simulation. We can easily import and export the information of the whole system subsystem integration. And component library is there. So that component library is basically for the designing of electric machine, gearbox, inverter, and the battery management system. So this information will be present there. And now you have designed your whole system, and now you are connecting in it as a architecture form and connecting in a powertrain system format. Like you have connected a battery using a bus bar, you have connected with the inverter and the buses, motor, and the gear is there. And the next step, like you have designed your one architecture, now you just want to change the battery, so you can easily change that battery part. You want to change the motor part, so you can easily change the motor part. So that was the thing which involved in this. Like you can easily your one architecture design, you can easily change. Like fuel cell library is there, you can also change it. If vehicle dynamic library is there, you can easily change it. And you, if you want to change anything related to heat exchange, and so this will basically give you, like if you have designed for any one car, you can easily able to change the range. You can easily able to change the other things. So that will basically give you a benefit like 50% saving of construction, or if you are going for one designing to the other designing. So that will basically by using answers you will get the advantage of this. And the next is the what was the multi-level and what was the multi-fidelity. Like you have information in the form of 3D multiphysics, and you can also have the information in the design DOE, design of experiment, or the measured data. So you, what you have to do, you just have to put the whole information. And and by using that whole information, it will basically like requirement and what was the specification of the EV, and what was the subsystem design of the EV. So and after we have to go for optimization. So these information will be given to one system, and then we will analyze our whole architecture. And by using that whole architecture designed, we will finally we can conclude that, like we have a motor, we have a battery, and that will be giving us that type of particular information. And that is the driving cycle of the battery, which motor which we are using. So that will basically, yeah, give you information, whole information about DB. And that created, or the that whole system will basically uh, reusable. So you can reuse that existing model. And now you have a system integration part. Like in that you can see here, you have a battery system power source, and that will be connected to the power inverter, where I already discussed, like we are using IGBT or the MOSFET or any other devices according to our need. And then using the power cable, we have connected a traction motor PMSM. and that load is connected now, and by using the embedded control we are controlling the information which we are getting from the electric vehicle, or we are also giving information and using that information to control the inverter subsystems. Like you can see here, a powertrain is there, and inverter is connected to the inverter system, and that inverter system consists of magnetic component part is there. So what was the behavior of that magnetic component? We just have to look into that, and this will basically reduce the cost of hardware devices, and this will basically help you the giving the real time information. And then we require a embedded software. That embedded software will basically used in V and B validation, value and validation process. So in that we designed and model, already modeled, and now we will get a code, and the software model test will basically give you what was the what was the performance of my vehicle, and what was the in-tune design of my vehicle. So and this will basically improve your accelerate your whole process before going to B&B process, and this will reusable, and this will basically increase the whole efficiency of the system. If you are using one system and going to the other system, so you just use that template, and that template will be helpful, and this will basically reduce the and minimize the software uh, detail. Okay, and the next step is to and you can easily detect the error also. Like you can see here in this vehicle, people are basically using a solar rooftop. You can also use hybrid, like solar system will be connected for running the music system and for running the other things, and not for the battery. We can also design our electric vehicle like that. Like other essential things will be run on the solar, like if you have a AC in your car, and that AC required lots of power, so that AC will be control or look after by solar, and other battery will be looked up, and other system will be looking for the battery system. Battery will be connected to the motor part only. So you can separate the things like that on that, like that, to make your car or electric vehicle more efficient. And the next is to provide a functional safety, and what was the certificate related to that functional safety, like ISO 2026 262 and IEC 61508. So these are the basically a functional safety certificate is required going for like you have designed your electric vehicle, and your electric vehicle is also working fine, but you required some information, safety certificate is also required for before going for prototyping part, and that required a HAZOP and FTA analysis and the FMEDA analysis. So these analysis will be easily done it, and you can also check the what was the system oriented solution for the consistency and traceability, and this will basically benefit you. Like how it will benefit you, it will up to 57% effort to the market will be reduced, and this will basically give you a complexity will be for the high performance, and the additional cost saving will increase. And this powertrain required ANSYS product. That product we already know, that product is also used for the battery and the motor and the power electronics devices. And you can see here ANSYS SCADE is only added, and the ANSYS twin builder is already there. Fluent and the Maxwell and the mechanical is already there, so you just don't have to worry about that. Like that much software is enough for designing the EV. And now we have an open environment, like you have designed your battery, you have designed the power electronics and whole system, and now by using the simulation of the system you just want to validate it. So validation part is there. So for validating you require a simulation result, and that simulation result will be given to the model and the physical test and the measure data, and that will be given to the HIL hardware in loop part by using FPGA or any other component and CPU. Between CPU, this will and the signal conditioning will be there. So that will co-simulation between co-simulation exchange between the data and the hardware in loop data will be happen to provide you a correct information and reliable result between the software and the hardware part. So I just listed out all the products here related to ANSYS. So we already discussed these things like ANSYS mechanical required, EMFC and these things. And the next are the research area. So if you are a MTech or BTech or any other student and you are want to do the research related to EV, so there you can see we have for the machine part what new you want to do. You can also design your new motor topology. You can do the safety and the reliability test for the motor. You can also do the like controlling part, like motor control is there. So how I will control at, and up to what extent I will able to control, and what was the braking and the braking system I'm using. For example, you can take like if you are your electric vehicle is going in up in the hill, so that part force of the gradient is very important, and that you just have to take care. Okay, so that force part is a very important part, and there you will look into that gradient force will be more than your aerodynamic force, more than your rolling resistance force, so that you just have to take care. And what was the control system I can use there. So and for that you can see if right now regenerative braking is up to 30% or 40% is used in electric vehicle. But if the regenerative braking efficiency will increase up to 70% range or 80%, so that will be very beneficial for EV design. Like your electric vehicle, you are going up to the hill and you are coming down to the hill. If regenerative braking is 100%, then there is no loss in between these two transition, means minimum losses up. But right now what it is happening, it is when you are going up to the hill, you required so much amount of battery, but going down, your regenerative braking is not that much enough to recharge your battery up to that extent. So that part is also a very important right now when you are going for that EV part, electric vehicle designing part. And then we have high efficiency machines should be required, and the size of the machine should be weight, and the power density ratio will also a very important factor for the research point of view. And going to that battery pack, we have lots of thing to do in research, like lithium ion battery is there, how to change it and replace that. And like if you have a battery and you just want to use that cooling, and like thermoelectric effect is also there. So that heat part and the from the cool part, can we generate a certain amount of better voltage or certain amount of energy power from there. So that can be also used, and people are also looking for that, because when we are using vehicle, batteries are getting heated up. And so that is also a very important point for the research. And what was the thermal packing of my battery, and series parallel connection of the battery, and how we are doing the fast charging, and the wireless charging is the hot topic right nowadays. People are basically interested in the wireless charging of your electric vehicle part. And for even mobile phone, they are interested in wireless charging. So that you just have to check it, and you just have to do the research on that. And how we will do whole process, like say integration and connection or cascading machine with the battery. You require power electronics devices, and power electronics devices, like how I will reduce the number of switches. Why we basically want to reduce the numbers of switches? Because we want to reduce the switching loss related to that. And how we can design the regenerative braking is there, like, and how we can give information of the regenerative braking to the battery system. For that you require a battery or the motor control system design that will comes under the power electronics devices. And if you want to create a charger for that battery, electric vehicle battery, but that battery is non-linear in nature, so this will basically deteriorate the power factor of your system. So that power factor improvement is also a very important, and research point of view, the power factor deterioration due to charging will also, you just have to check it. And people are all nowadays interested, like if you are charging your coal energy is there, and from coal you are producing electricity, and that electricity you are using for the electric vehicle. But right now people are interested in green energy, like you just have to connect one solar panel, and you connect a one DC-DC converter, and that DC-DC converter will basically give information like maximum power point tracking, and from that maximum power you will charge your battery. So that will be basically a green energy initiative. So you involve when you are going for designing your electric vehicle, because we are selecting electric vehicle, and we are also doing and selecting electric vehicle for the our environmental thing. So we just want green and clean energy. So for that you can use solar, and that solar energy will help you to charge your electric vehicle. So and after designing whole three things, we just have to make the system like that. Co simulation technique should be work fine, energy management system should be perfect to reduce the size of the battery and the even size of the motor, to make our electric vehicle more spacious, and to make our electric vehicle efficiency should be high. So then we have to basically compete with the IC engines that are designed. So we just have to check like what was the efficiency of the IC engines is nearly 25% to 30%, and here we have electric vehicle motor like for the 90%. So we just have to check that. And in ideal condition, if your machine is in ideal condition, your EV is in ideal condition, so then it required very less amount of energy. But for the petrol engine, it requires energy. So you just have these advantages of EVs comparing to ICs. So what was the opportunities for the student for going for EVs? What was the opportunity and what was the advantage they are getting? So you can see here like battery design. So these are the, I have just listed down the top like battery design and the department related to that, like chemical, material science, mechanical, aerospace, and automobile. They can come together and for the designing of battery. And if electronics devices, they are power electronics people, mechanical people, automobile, electrical, aerospace. So these they will come under the one roof, and they can also design the perfect design for the power electronics devices and electromagnetic solution. They will provide us like electrical, mechanical, and the aerospace. And these are the job opportunity related to EV related skill, like scientific research they can do. They can also do the design and development part. They can also do the manufacturing, maintenance, and infrastructure development, and not but the least sales and support they will provide for the EVs. Like in EVs, there are design engineer option is also there for the EV design. So they can also do that for the electrical people. They can do the designing of the motor. They can make the efficient EV system, and like they can also do the designing of new motor and designing of new topology they can use in the for boosting and bucking the voltage. So like you can see here, simulation is acceleration for EV, and in that our lucid motor is there, so that they will basically increase their efficiency up to 12% more by using our co-simulation and the multi-physics simulation part. They will basically get benefits from for using ANSYS. How they are doing, they are basically using a perfect thermal management system for their motor to cooling their motor. So this will basically increase the efficiency of their motor. And uh, ANSYS also provide you a ANSYS innovative courses, and in that ANSYS innovative courses you will get a scope for that, and that AICs are basically developed by industries people, and and there are many people involved in that area, so they will basically help you from design your electric vehicle from scratch to hardware, full professional part. So you will also collaborate with the academic team for designing of that, like many, or if you are going for your startup part, like one right now there is one startup is going on. I don't know the date is over or not, for the women entrepreneur. They are providing information, they just say STPI. You can also search it, STPI is there. So from there you can also apply for the startup program. Initiative by the government of India is there, and they will basically collaborate with you to design any new technology if you are interested in, like green energy or EV system or any other. So you can also put your idea, and you can also pitch your idea there in at STPs. Like Chanakya 2.0 is 20, they have started their program in 2020, and now they are also giving you support for the women entrepreneur this time. So Answers will also provide you Answers Learning Hub, and that Learning Hub will basically give you information, all data, and the other things, like if you are designing, if you are new to this motor designing part and you don't know how I will proceed and what was the blueprint I will have to follow for designing of my whole system and how I can behave. So this Answers Learning Hub will basically provide you, give you a platform for like a structure, LS Dyna system and the fluid. So whole thing will be, and more many more examples are there. So this will basically help you in improving or making your career, and increase your resume. You can also put that. And the next year in that ANSYS Learning Hub, you will also get information like learning management system, and this will also give you like productive and tools. Most of the tools are there, and self-paced learning courses are also available. So you can also, by using that self-paced learning courses, you will also learn, and you can also design your electric vehicle, and you can also do other analysis there. Easily you can do that, and they will also provide you a live classroom and the live virtual classes for other informations. And this will basically give you welcome to the fluid building are there. So this will basically, like if I am interested in designing of a low frequency, and so for that I required Maxwell for the low frequency part, and there you have to electrical machine, power electronics, and designing of transformer, whole information will be there. If you are interested in high performance and like designing of antenna, 5G technology, so for that you require a electromagnetic building. And if you are doing do want to do the crash analysis of your motor, so and crash analysis of your battery or the EV system, you required LS Dyna for that. Like you can see here, LS Dyna is there, and that LS Dyna will basically give you information about the crash analysis. Okay, so I think we have questions in the chat box, so we will first look into that. Okay, kindly throw more light on design and development job. Okay, so in design and development, you will get a job related to like a design engineer job is there, and like design engineer for the power BLDC motor. Somewhere in the LinkedIn, you will find the link for that. Like design engineer for the BLDC, they required. Sometimes they required design engineer related to PMSM, and basically you will get a job related to power electronics controlling part. And like if you are running your motor, and what and how I can control my motor. So that will very important when you are searching for a job. And like if you are interested in battery management system, there also there lots of scope is there. And you can also do like sometimes they require DC-DC converter, and sometimes they required an engineer who knows how to connect that DC-DC converter, and how to connect that DC-DC converter with the whole um, EV machine. So you can also search for the job for the design and development of converter part, design and development for the inverter part, and design and development for the EV system, whole EV system. You can also get that. Software which I will suggest, you can search, you can use Answers for that. Answers will basically give you full access for that. So you can use Answers, or if you want to go for a startup, or if you want to get funded, so for that you just have to type STP Chunauti 2.0. uh, it is widely used by industry like Lucid Motor. I already showed you they have reduced that. uh, okay, so I will provide you the link of that startup after this presentation. I will type that and you will get it. And many other many other program also run by IITs and ITs, and even colleges, good colleges. They will basically provide you fund for your starting. Like if you are doing like FIST program is there for the professors. Right now a FIST program, FIST program is running by the government of India for the getting the fund for the department. So from any department can apply for that. So from there you will also get a fund for doing your research project. So FIST program is there, and mm, likewise many other information you will get it. Okay. The next after that, the next thing is the Answers campus building is there, and that building will basically give you, like you have an idea and you just want to block your idea, and you just want to put your idea, and you just want fast calculation of your idea. So Answers discovery is there. So by using that Answers discovery, easy to use tools are available there, and from there you just have to pack your idea there. And in the and many tutorials are also available in the Answers discovery part, and there you will they will give you information. Like if you are starting your career for designing of motor, and you don't have basic knowledge, so from there Answers Learning Hub will basically provide you information like how I will start, and how I will proceed, and how I will change the design part. So you can also do that. And this will basically like Answers Learning Hub private room, and customization is there. Okay. And you can also do that by using that. Many examples are already present there in the customer portal. Like if you are Answers employee, you have Answers, so you can directly use that. Okay. Right now it's okay. Now we have a Answers Learning Hub, and from that Answers Learning Hub will basically give you more information about the like how we proceed, and how we this will basically give you a blueprint for getting information, and many other things are also involved in that. So you can also check with the Answers website. And these are the private rooms and the customizations. Like you can see here, Answers Learning Hub account is there, that is increasing day by day, and that private rooms and the public rooms are available, and many examples are there. So you can also use that things for improvement. And now Answers for the student version is also free. So you can also look into that Answers website for the free software, and you can also design your motor, and the Answers motor CAD is also there, so you can also do that. And you can also designing and the other things you can also do that. Now I am open for question answers. So any participant have any question? I am open for question answer.
Participants, the session is open for question answers. You can either post your question there in chat box or you can directly ask question to sir.
Sir, one question from my side.
Okay, sir.
Sir, for thermal analysis of batteries, what kind of package ANSYS is providing? Means, what are the modules that we should have for a complete battery management?
Sir, for complete battery management.
I'm talking about only thermal part. Yes.
Okay. So for thermal, you only required one software, ANSYS CFD. So for the thermal management, that CFD will basically consist of mechanical part, and in that mechanical you will get a thermal option there. So for the fluid option, you will also use that only. Only one software is basically
Only
required.
one software. Okay.
For the
Thank
thermal
you.
part.
Any question? So if there are no questions, then we can end the session. So we will wait for some time if there are questions.
Okay, yes, sir. We will wait up to that time, sir, 2 o'clock.
Yes. Amol sir, kindly post the feedback link in chat box.
Yes, sir.
Feedback link is there in the chat box.
Sir, can I get the feedback link of today's session? This session, sir.
Yes, it is.
Sir, for my future reference, sir. Can you share it with me?
Yes, sir. Definitely, we'll check.
Okay. Thank you, sir. Otherwise, I will share my feedback link if you. And sir, in your college, you people are doing that EV part, na? That electric vehicle research is going on, na?
Yes, sir. Hello. Kartikesh sir, you can
Yes,
share
sir.
the link with me, so I can post it in the WhatsApp group. So you will get the feedback directly from the participants.
Okay, can I post it here in the
Yeah,
chat?
yeah.
Amol sir, can I propose a vote of thanks for this session?
Yes, sir. After
Uh,
that, we will take one photograph. Of
yes.
all the participants.
Thank you, Kartikesh Kumar sir, for the detailed analysis of battery and its important segments. You have explained battery management systems and battery designs very well. On behalf of Shah Institute of Technology, I'm so much thankful to you for this wonderful session. And I'm also thankful to all the participants. Here I announce that the second session of today is done. And I would like to say that our third session will start by 2:30 p.m. today. Link is already shared in chat box. All are requested to on your cameras so that we can go for the photo session. Amit sir, kindly reply once it is done.
Yes, sir. It is done.
Okay. Thank you, sir. Thank you all.
Hello. Hello.
Yes, sir.
Yes, sir. Yes, sir.
Sir, the recording of yesterday's session, I think it is not shared on our WhatsApp group, no? Is it there?
Yeah, sir. We have uploaded it.
So it is there on WhatsApp, right?
Yeah, you can check it in YouTube channel that we have shared yesterday.
Okay, fine. And today's all the recordings will be shared in the evening.
In the evening or by tomorrow, we'll share.
Okay, fine.
Yeah.
Okay, thank you so much.